All right. I don't think today's day was too difficult, and part two is pretty quick, so let's just go ahead and jump right into it. So basically, we're going to get our inputs like this. Let's go ahead and read this first. So what I'm going to do is I'm going to save these into a list of numbers. So int nums is equal to list map int. Let's this. So what this is, we're going to do a list combination. Input dot split lines. So what this is going to do is for each line in our split lines, we're going to call this little idiom where we split everything in that line and then turn it into an integer and turn it back into a list. If I print this out on the test case, we can see we're reading the input properly. So here you can see it's like this. This is all good. And also just a little sanity check. If I run this on my actual input, when I was doing this, my bug that I was sitting with a while is I wasn't reading negative numbers because I was using regex. But yeah, so this works perfectly. So now that we have that, let's go ahead and actually write the meat of our code. So basically for this day, other than one small optimization, you more or less just kind of brute force it. And so what I did was, when you have something like this, you're going to go ahead and do here. We'll create a function called solve, and it's going to take in some numbers. And this is going to be a recursive function. So we're going to have some base case, which I'll get to in a little bit. And then we're going to go ahead and actually just do like the whole difference thing. So difference is equal to this. And then for I in range, len nums minus 1. And we're going to go ahead and just write down the difference here. So we'll do diff dot append nums I plus 1 minus nums I, just like this. So now we have our difference. We'll go ahead and return our nums, our last element there, plus whatever we get for solving or like calling a recursive function on the below one. And so if I kind of explain why we're doing this, so imagine we're getting this, we're on currently this line. When I pass this in, I'm going to calculate all the differences, which is this, and then I want to return, like eventually my entire function should return this number right here. And so what we're doing is when we take this as an input, we go ahead and calculate our diff using this whole thing right here. And then we finally go ahead and return our last number plus whatever the extra number is on our diff. So we basically return this last number plus whatever this number is. So then we go down here and we solve it again. And then here we get our differences. We hit our base case, and so we end up returning this 0, which is the new number on this row. And then we go up level and we hit back to this line and the recursion, and we see 3, we return plus 0, and we'll get 3 here. We go back up again and we see 15 plus 3 and we get 18 here. So now for our base case. What you could do is something like if all n is equal to 0 for n in nums. If we have something like this, then we go ahead and return 0. So this is what they basically had, where if you eventually end up with a list where it's all zeros, then go ahead and return the 0. And if I go ahead and run this on the test case, let's actually return it. We'll do solve, and we'll do sum all these together. So for n in input nums. So we're going to call solve on basically every input we get. If I run this, I'm going to need to return something from my test suite. So here, we're getting 114, which is right. And if I go ahead and actually run it on my input, I get the right answer, and you can see when I submit it, this is solved. But, so one thing that you can do to speed this up, and so if you look at the time, it takes 10 milliseconds, which is fine, not bad. But one thing is, if you look, when you get to a row of all zeros, the row before it is basically going to be a list of all the exact same number. And the new number is going to be that same number. So let's go ahead and just save one level of recursion by doing this instead. If set nums is equal, or if the length of this, so if I turn into a set which gets rid of duplicates, this ends up with only one element in it, then let's just go ahead and return that element. So now if I run this, you can see, takes, all right, well, that's not ideal. But all right, I guess I'll go ahead and comment both of these out for now, and we'll see at the end, because I did end up seeing that it was faster. All right, or not. Here, let me go ahead and just copy it down for my other one. All right. So if I go ahead and comment this out, let's see. All right, I guess this is just pretty variable right now. So, all right, we'll see in a second. All right, okay. But so now this is part one done. For part two, we're just going to do this with the first number instead. So all we have to do is a nice little trick I saw from someone else's solution is here. We can just go ahead and call solve, except we'll just reverse our list here. And by doing this, basically, we're just flipping it left to right, and then we're ending up solving for the front instead of the back. If I run this, we get this, our solution is correct. And then if I go ahead and now test out this, we can see that it's drastically faster. Don't ask me why it wasn't working earlier, but it's faster now. So we can see it runs in 9 milliseconds. Or not, I'm gonna go insane. All right, either way, it's a fast solution. Overall, it works. So yeah, hopefully this was a fun day. Good luck.